Alright, and so the easiest way to do a binomial expansion is to use Pascal's triangles. That's what we're going to look at first. Okay, so Pascal's triangle is a pattern that gives you your leading coefficients of any binomial expansion. So it always has ones along the outside, and then you add the numbers to get to the inside. So 1 plus 1 gave me 2, 2 plus 1 gives me 3, 3 plus 1 gives me 4, etc. And so you add to get to your next row. And so that works always. And it goes on forever, but I only included the first 6 rows because we won't deal with exponents bigger than 6, typically. So everybody got that? Makes sense. Alright, so the number of rows correlates to your exponent that you're going to use. Okay, so if I look at x plus 1 cubed, I know that that 3 tells me that I'm going to use row 3's coefficients, which are 1, 3, 3, and 1. Okay. And then we look at our terms. So x is one of my terms, and you take your exponents and you put them in biggest to smallest order for your first term. And then for your second term, you put those exponents in smallest to biggest order. And then we simplify. 1 to the 0 is 1. 1 times 1 is 1. So 1x cubed is my first term. 1 to the first is 1. 1 times 3 is 3. So 3x squared becomes my second term. 1 squared is 1. 1 times 3 is 3. So 3x to the first. So 3x becomes my third term. And lastly, 1 cubed is 1. 1 times 1 is 1. X to the 0 is also 1. So just 1 is my last term. And then you're done with that expansion. So it's used when looking at really big exponents, so you don't have to FOIL a bunch of times. Okay. So if I look at example 4b, I'm asked to expand x plus 2 to the 4th. So since I'm looking at my fourth exponent, I'm going to use row 4, which is 1, 5, 10, 10, 5, 1, I think. 1, 2, 3, 4. Oh, no, that's row 6. Just kidding. Row 4 is what? 1, 4, 6, 4, 1. Is that right? Yeah, okay. So that's a little better. Then we take our first term, so x, and we write our exponents in descending order. So x to the fourth, x cubed, x squared, x to the first, x to the 0. And then you write your second term in ascending order. So 2 to the 0, 2 to the first, 2 squared, cubed, 2 to the fourth. Okay, so 2 to the 0 is 1, 1 times 1 is 1, so 1x to the fourth is my first term. 2 to the first is 2, 2 times 4 is 8, so 8x cubed becomes my second term. 2 squared is 4, 4 times 6 is 24, so 24x squared becomes my third term. 2 cubed is 8 times 4 is 32. X becomes my fourth term. And 2 to the fourth is 16. 16 times 1 is 16. X to the 0 is 1, so just 16. Pretty straightforward. Gonna do one more? Two more? One more? Okay. That one will work. Alright, so 2x minus 3 to the fourth. Okay, so my fourth exponent tells me to use my fourth row. So 1, 4, 6, 4, 1. Okay. Then if I look at my first term, 2x to the fourth, and then I write those in descending order. 2x cubed, 2x squared, 2x to the first, 2x to the 0. And then I write my third term in a descending order. So negative 3 to the 0, negative 3 to the first, negative 3 squared, negative 3 cubed, negative 3 to the fourth. Okay. Well, negative 3 to the 0 is just 1. 1 times 1 is 1. 2 to the fourth gives me 16. 16 times 1 gives me 16. So I have to multiply all my coefficients. And then I'm left with x to the fourth. I keep doing that. Negative 3 to the first is negative 3. Negative 3 times 4 gives me negative 12. 2 cubed gives me 8. Negative 12 times 8 is negative 96. X cubed. Negative 3 squared is 9. 9 times 6 is 54. 2 squared is 4. 54 times 4 is 216. And then I'm left with x squared. if I look at my fourth term, negative 3 cubed gives me negative 27 times 4. I don't know, what's negative 27 times 4? Anybody? I think it's like 112, but I don't want to get this wrong. 108? Okay, so negative 108. And 2 to the first is 2, so negative 108 times 2 is negative 216 again. X to the first, so just x. And then lastly, negative 3 to the fourth gives me, what, anybody? I don't know what 3 to the fourth is. 81? Okay. So then gives me 81, 2x to the 0. 2 to the 0 is 1, so I get 1 times 81, which is just 81, and the x's are gone. Okay, so there's our binomial expansion. Can I do one more? Is that good? I don't know what you're nodding to. You're good? Good, good, okay. All right, 686, 5 through 38.